Hello everyone, this is J. Upendra Kumar, Assistant Professor Civil Engineering Department. The subject is Structural Analysis and the topic is Analysis of a Fixed Beam of Varying Flexural Rigidity. Hello everyone, in this class I am going to explain an example of a fixed beam analysis of varying flexural rigidity. So this is our beam of point load 3000 newtons acting eccentrically, that is 2 meters from left end and 4 meters from right end. And our flexural rigidity is varying here. It is I in the span AC and 2I in the span of BC. So the analysis of a fixed beam consists of two steps. First step is drawing the bending moment diagrams of simply supported case and fixed case. And the second step consists of applying the compatibility equations. That is area of mu diagram by EI plus area of mu dash diagram by EI is equal to 0, and deflection at any point of simply supported case plus fixed case is equal to 0 divided by EI. So in the previous problems where it is of same flexural rigidity, we neglected this EI value. But coming to this case, we will not neglect this EI value. We will substitute this EI value in this compatibility equations we will solve. So remaining procedure is of same. So coming to this problem, the first step is to divide this fixed beam into a simply supported case and fixed case. So this is my simply supported case and this is fixed case. So coming to simply supported case, I am analyzing this simply supported case to draw the bending moment diagram. So the summation of the vertical forces is equal to 0. That is RA plus RB is equal to 3000. Here it is 3000, not 3600. Correct it. And coming to the moment, moment at A is equal to 0. The forces acting for this moment are RB and 3000. So the moment due to RB will be RB into span 6. So it will be positive since it is acting anti-clockwise in the right side direction. So RB into 6 is positive, and coming to this 3000, moment will be 3000 into 2 and it will be negative since it is acting clockwise direction on the right side. So it will be 3000 into 2. So RB into 6 minus 3000 into 2 is equal to 0. So by solving this, we will get RB value as 1000 newtons. Now by substituting this 1000 newtons RB value here, we will get RA value as 3000 minus 1000, that will be 2000 newtons. So we got our RA value as 2000 and RB value as 1000. Now coming to bending moment diagram, moment at A is equal to 0 and moment at B is equal to 0 since simply supported cases. Now coming to C, moment at C, we can consider either left side of the section or right side of the section. Here I am considering the right side of the section. The forces on left side of the section are only RA. So the moment due to this RA will be RA into 2 and it will be positive since it is clockwise moment acting left side. So RA into 2 is my moment at C. RA value is 2000. So moment at C is 2000 into 2, that is 4000 Newton meters. Now by marking this 4000 newtons and joining with straight lines, got bending moment of simply supported case as a triangular shape of height 4000. So this is simply supported case, which is mu diagram. Now coming to fixed case. This is fixed case. So since the load is not symmetrical, the bending moment diagram will be in the shape of trapezoidal shape. So MA, this is MB, and the span is 6 meters. This is a mu dash diagram. Now applying compatibility equation. The first compatibility equation is area of mu diagram by EI plus area of mu dash diagram by EI is equal to 0. In this case, we will deal both these spans with as different sections, since here it is I and here it is 2I. Similarly, here also we will we will break this into two sections of flexural rigidity I and flexural rigidity 2I. So coming to mu diagram. This is mu diagram. So I will first calculate area of mu diagram by EI value. Later I will calculate area of mu dash diagram by EI value. Then I will add both them and equate it to 0. So here the area of mu diagram is, I divided this bending moment diagram into two sections. One section of flexural rigidity I and second section of flexural rigidity 2I. So here it will be, area is half base is 2 into 4000, height is 4000, half base into height. So this will be my area, and EI is same, EI. Coming to this section, the area is half 4 into 4000 divided by E into 2I, 2EI. So this is my area of mu diagram. This area is half base into height, half 2 into 4000 divided by EI, and this one becomes half 4 into 4000 divided by E into 2I, that is 2EI. So by calculating this, we will get area of mu diagram by EI value as 8000 by EI. 8000 by EI. Coming to this mu dash diagram, I had marked the remaining sections with another ink for easing the calculation. So first we have to divide this into two sections, I and first one of flexural I and second one of flexural rigidity 2I. So from in the span of AC, the flexural rigidity is I, and in the span of BC it is 2I. So I divided it into two sections. Now coming to this divisions, to make the calculation easier, I had divided this part into rectangles and triangles. So by dividing this one into a rectangle and a triangle, we will get it as this height is of MB and the remaining this part as MA minus MB. But we will deal this separately and this one separately. So again we have to know this value also. So for calculating this value, we will consider only this triangle. This is our triangle. This is MA minus MB, and this distance is X. Let us consider it as X, and this is 0. So by taking similar triangles, this one as a triangle and this one is another triangle. So by considering similar triangles, MA minus MB by 6 is equal to X by 4. Okay, MA minus MB divided by this total span 6 is equal to X divided by this span, that is 4. So by solving this, we will get X value as 2MA minus 2MB by 3. Clear? So this value is 2MA minus 2MB by 3. Now I had divided this span into a rectangle and a triangle. Now coming to this one, this shape has to be divided into a rectangle and a triangle. So we know that from here to here, so here to here it is 2MA minus 2MB by 3. So from here to here it will be 2MA minus 2MB by 3 plus MB. Okay? 2MA minus 2MB by 3 plus MB will be the span from here to here, that is 2MA plus MB by 3. So this is 2MA plus MB by 3. So now we need to calculate this value. This is the height of this rectangle, and we have to calculate the height of this triangle, this smaller triangle. So this height will be, this total height is 2MA minus 2MB by 3, and this total height is 2MA plus MB by 3. So now total MA minus, this is our total MA from here to here. So total MA minus this value, that is 2MA plus MB by 3, will give you this value. MA minus 2MA plus MB by 3 will give us this value, that is MA minus MB by 3. So this is our MA minus MB by 3 value. So now we had calculated all the values here. Now we have to calculate area of mu dash diagram by EI value. So now coming to this one, area of mu dash diagram, first I am considering this rectangular part. So first I am considering this rectangular part. This is MB into 4 is the area of this rectangular part divided by E into 2I. This is for this section. And coming to this triangular part, half base into height, half 4 is my base and height is 2MA minus 2MB by 3. Clear? Divided by E into 2I, that is 2EI. So this is for this section of flexural rigidity 2I. And coming to this section, for this rectangular part, it is this is the length and this is the breadth, that is 2 MA plus MB by 3 into 2 is the area divided by EI. Coming to this triangular part, it will be half, base is 2 and height is MA minus MB by 3 divided by EI. So this is area of mu dash diagram by EI value. So now by solving this value, area of mu dash diagram by EI value, we will get the value as 14 MA plus 10 MB by 6 EI. Okay, I have taken the LCM for this 2 EI, 6 EI, 3 EI and 6 EI, and I have solved this one. So by solving this, we will get area of mu dash diagram by EI value as 14 MA plus 10 MB by 6 EI. So now we had calculated area of mu diagram by EI value and area of mu dash diagram by EI value. By substituting these values here and solving it, we will get an equation, that is 7 MA plus 5 MB is equal to minus 24,000. So marking it as 1. Here area of mu diagram value is 8000 by EI and area of mu dash diagram by EI value is 14 MA plus 10 MB by 6 EI. So by calculating this, we will get 7 MA plus 5 MB is equal to minus 24,000 as equation 1. Now the second compatibility equation is delta AS plus delta AI is equal to 0. This is my simply supported case bending moment diagram, that is mu diagram. Now using moment area method, the deflection value will be calculated using this formula AX bar by EA. Now we are calculating the deflection at this point A. So for this section, the AX bar will be half base into height. So half 2 into height is 4000. This is my area, and X bar value from here it will be 2/3 of this span, that is 2/3 of 2 divided by EI value is same, since I is here the flexural rigidity is I. Coming to this section, area is half, base is 4 and height is 4000. This is area, and X bar value here will be, from here it will be 1/3 of 4 plus this 2 gives me the length from here, X bar value from here to this point. So the X bar value is 2 plus 1/3 of 4 divided by EI. Here I is 2I in this section, so 2EI. Now by solving this value, I got it as 5333.33 by EI, and this value as 13333.33 by EI. And by adding this, I got delta AS as 18666.66 divided by EI. This is delta AS value. Coming to delta AI, again I am taking the same considerations, these values, and again I have to solve all this, a rectangle, a triangle, again here a rectangle and a triangle. So delta AI, so area of this rectangle is 2 MA plus MB by 3 into this length L into B. So this length is 2. So this is area of this rectangular part, and X bar value here will be, from here it will be at the center, so 1 by 2 into 2. This is my AX bar, and EI is same EI, since the flexural rigidity here is I. And coming to this triangular part, the area is half, base is 2 and height is MA minus MB by 3. So this is my area, and X bar value here, from here it will be 1/3 of this span, that is 1/3 of 2 divided by EI, since flexural rigidity here is I. Coming to this section, for this rectangular part, the area will be MB into 4, and X bar value from here it will be half of 4 plus 2 from here. So from here the X bar value is 2 plus half of 4 divided by E into 2I, since flexural rigidity here is 2I. Coming to this triangular part, the area is half base is 4 and height is 2 MA minus 2 MB by 3. So this is my area, and x bar value from here it will be 1/3 of the span. From here it will be 2 plus 1/3 of this span, that is 2 plus 1/3 of 4 divided by 2 EI. Here flexural rigidity is 2I. So now by solving all these values, I got this value as 4 MB plus 2 MB by 3 EI. This value as 2 MA minus 2 MB by 9 EI. And this one as 8 MB by EI. And this value as 13.33 MA minus 13.33 MB by 6 EI. Now, taking LCM and solving it, I got deflection at A of a fixed cases 68 MA plus 112 MB by 18 EI. So we had calculated delta AS value, that is 18666.66 by EI, and delta A value is 68 MA plus 112 MB by 18 EI. Now by substituting both these values in the compatibility equation, delta S plus delta AI is equal to 0, and solving it, we will get another equation, that is 68 MA plus 112 MB is equal to minus 336,006. Mark it as equation 2. Now we got two equations from two compatibility equations. First equation is 7 MA plus 5 MB is equal to minus 24,000. Second equation is 68 MA plus 112 MB is equal to minus 63,606. So now by solving both these equations, we will get MA value as minus 2270 Newton meters and MB value as minus 1621.72 Newton meters. So this is our beam. These are the forces RA and RB value. RA as 2000 and RB as 1000 newtons. So now coming to bending moment diagram. This is the bending moment diagram of simply supported case. Here it is 0 and here it is 0 and here at C it is 4000 positive. Coming to this fixed case, we got MA value as minus 2270 and MB value as minus 1621. Marked both these values and joined them using a straight line. So these values are negative. This is bending moment diagram of this fixed beam. And coming to the shear force diagram, here it is 2000 plus. Coming to this point, we will subtract this 3000. Till here it is 2000. From here to this point, it will be 2000 minus this 3000, that is minus 1000. So this is the shear force diagram. This is how we will analyze a fixed beam of varying flexural rigidity. Thank you.